Hi guys, welcome back. In this video, what I'm going to do is I'm going to be showing you how to graph a quadratic function in a particular format. Now, I do have a previous video on this when it's in a turning point form, so go check that one out. But this one's going to be talking about looking at quadratic formulas when they're in a root form and how to graph them and find particular features of them as well. Okay, so let's have a look. So I'm going to looking carefully at this form here, y equals a, x take b, x take c. Now, here you can see I've got some little hints and tips to show you about how to actually find some of those particular features when given to you in this format. Okay, so let's have a look. My y-intercept, I can find my y-intercept when I let x equal 0, and I can just rearrange and solve for y. This is because when you've got y-intercept, it's going to be on the y-axis where x equals 0. So that's why that works. Okay, and I can put that coordinate in and just see what my y-intercept is going to be. Okay. Now, if I want to find my x-intercepts, they're just my roots. I can use my formula or my equation in this given format here to find out the x-intercept. So I've got B and C. Now those are going to be my intercepts, and just noting the fact that they are indeed negative, similar to the turning point form, so just note that for when you're trying to find your x-intercepts. I've got my line of symmetry. The parabola hits the x-axis at B and C, so basically those coordinates there, and the line of symmetry is going to lie in between these 2 points. So if you imagine you've got, I don't know, like a quadratic that looks like this, right? If you've got your two roots here, your line of symmetry is going to be right smack bang in the middle between those two, like the middle point here between those two. So you're going to be using this formula here to try find the line of symmetry. Okay, let me just erase all this. Okay, now turning point, you basically substitute in your line of symmetry because I should have drawn it again. I'm going to draw it again. If you've got a quadratic and you've got your line of symmetry here, your turning point's always going to lie on that line of symmetry. So you substitute that in to find your turning point, and then you can determine whether or not it's a minimum or maximum shape based on this letter here. So if it's positive, it's going to be a minimum. If it's negative, it's going to be a maximum. All right, so let's see if we can have a go at a question together. All right, so let's have a look. So we've got here, for the graph of y equals x plus 1 x take 5, let's determine the coordinates of the y-axis intercept. We're going to determine the coordinates for the x-axis intercepts. I'm going to find the equation of the line of symmetry. And we're going to determine the nature, or minimum or maximum, and the location of the turning point or the coordinates. And then we're going to sketch it. All right, so let's have a look. So the first thing I'm going to do is going to find my y-axis intercept. So that means I'm going to let x equal 0. So I'm going to write it over here. So y is equal to, so whenever I see an x, I'm going to put 0 in there. Okay, now I'm going to just solve it. So I've got 1 and negative 5 here. So that tells me that my intercept is going to be at negative 5. So 0, negative 5. Okay, now I'm going to put that onto my graph here, just so that way I'm just prepared for that part E. All right, let's look at my next step. I'm going to try to find my x-axis intercepts, or my roots. Now, like I mentioned before, similar in my notes up here, they're going to be these two bits here. So right after the minus sign, or in that spot there, in that position. I have these two here. They're going to tell me what they are. Now, you do notice that this is a plus sign. That means that this particular root is going to be a negative. So this is going to be, that's part A. Part B is going to be negative 1, 0. That's my first one, because in my general format, it's negative. So it's a negative 1, 0, and then I'm going to have a positive 5, 0. So those are going to be the coordinates of my roots, or my x-intercepts. Part C, I'm going to find out the equation of the line of symmetry. Now, like I mentioned before, it's going to be that halfway point. So I'm going to use this formula here to work it out. So I'm going to use B and C. Now, this is B, this is C. So I'm going to go negative 1, remember, negative 1 plus 5, and divide it by 2. So this is my B plus C, essentially. Now I have 4 divided by 2, which is just 2. So that tells me that my line of symmetry is where x equals 2. Oh, I need to graph my roots. I'm going to graph these roots here to help me out. So I'm going to have negative 1, 0. So negative 1, 0, and I'm going to have 5, 0. And let's put in my axis of symmetry. I'm going to use a ruler to do that. So I'm going to just plot that in. Whoops, very terrible dotted line, but nonetheless. So I'm going to write that in there. Now let's find the nature and location of the turning point. Now you can see here there's nothing actually in the front of my rule here, my quadratic, but we always have to remember there's always a 1 there. If there's nothing there, we assume it's a 1. And because it's a positive 1, it's going to be a minimum. So let's write that down. So it's going to be a minimum graph. And let's find our turning point. So our turning point, okay, I'm going to let x equal 2 because remember, like I mentioned, the turning point is going to always lie on the axis of symmetry. So I'm going to find out what my coordinate is for when x equals 2. So I'm going to substitute x equals 2 into my rule, into my regular rule here. I'm going to substitute that in. So I'm going to go y is equal to 2 plus 1, 2 take 5. Alright, so I'm going to have 3 and minus 3, which is equal to minus 9. So it's telling me that the turning point is going to be at 2 minus 9. So let's do that. So 2 minus 9, that point there. Now I'm going to have enough information, enough kind of data or like little features so I can actually figure out what my graph's going to look like. Now I'm going to help myself out and figure out where some of these dots are on the other side. So I've got my roots. I just need to figure out the distance here. So this is 2 across this way. I'm going to put another spot here because it's the axis symmetry, they're symmetrical. I'm going to put those in. I'm going to erase these other little bits as well. Okay, and so now I'm going to be able to use my pen or pencil because it's graphing, of course. Try my best to do this. Hopefully you'll have more luck than I do. And there we go. I'm going to write in my specific points or my special features. So I'm going to put in my turning point. I've already put in my line of symmetry. I'm going to write down also my intercept, like I graphed at the very beginning. I'm going to put my roots in to also show that I've got my roots. Okay, there we go. So now we've perfectly graphed a quadratic when it's in the format of a root form.